Hi everyone! Today's video is about the groups on the periodic table, and it is brought to you by Help Young Minds, and I'm your host Arju Neupane. So in this video, we're going to talk about the different groups on the periodic table, which are the metals, the nonmetals, and the metalloids, and we are going to start with the metals. The first group that we'll go over are the metals, and in this periodic table, they're shown in that silvery blue color, and we're just going to go over some of the general properties that metals have. One of the properties is that they're all solid at standard temperature and pressure, other than mercury, which I have circled in red, which is a liquid at standard temperature and pressure. They're all very lustrous, which means that they're shiny. They're malleable, so they can be hammered into sheets without crumbling. They're ductile, so they can be stretched into thin wires without breaking apart. And they conduct heat and electricity very well. They also have very high melting and boiling points. And an example of a metal is sodium, and as you can see, it's very shiny and it has that metallic shine. And one other thing that I want to add is that metals tend to form cations and ionic bonds, which means that when they bond, they tend to lose electrons. The next group that we're going to talk about are the nonmetals, and in this periodic table, they're shown in that bronzy golden color. They're usually gas or solid at standard temperature and pressure, other than bromine, which I have circled in red, which tends to be a liquid at standard temperature and pressure. They're also very dull compared to metals, which are shiny. And they're not very malleable or ductile. Instead, we say that they're brittle, which means that they crumble or break apart really easily. And they also don't conduct heat and electricity. They also have variable melting and boiling points, so some of them have really high melting and boiling points, while others have really low melting and boiling points. Nonetheless, their melting and boiling points are usually lower than that of metals. An example of a nonmetal is phosphorus, and as you can see, it's not very shiny, it's very dull, and it's also very brittle, so you can imagine if you hold it in your hands, it would crumble very easily. Another thing I want to add is that nonmetals tend to form anions in ionic bonds, so they tend to gain electrons and become negative. And they can also form covalent bonds with other nonmetals, and they can share their electrons rather than giving up electrons or gaining electrons. And one specific nonmetal that I want to bring attention to is hydrogen, and it's not put along with the other nonmetals on the right side of the periodic table, and that's just because it has properties of a metal and a nonmetal, so it can either lose or gain an electron, and because of that, it can be put over here because it can lose an electron just like all the other atoms below it, such as lithium and sodium, which can also lose an electron. However, we do consider hydrogen a nonmetal because it does behave more like a nonmetal at standard temperature and pressure. Now we're going to look at the metalloids, and on this periodic table, they're shown in that green color. And I just wanted to mention, so for example, on this periodic table, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are considered metalloids, while other periodic tables might add astatine as a metalloid, or they might take out polonium and only consider the first 6 as metalloids. And that's just because metalloids have properties that are in between that of a metal and a nonmetal, and because of that, sometimes it can be hard to differentiate between what is a metalloid and what is simply a non-metal, or what is a metalloid and what is simply a metal, for example. So because of that, this staircase might look a bit different on different periodic tables. And like I mentioned before, metalloids have properties that are in between that of a metal and a non-metal. So some are shiny while others are dull. Some are malleable or ductile while others are brittle. Usually they do conduct heat and electricity, although not as well as metals do. And an example of a metalloid is silicon, and in this picture you can see that it's very shiny like a metal. However, silicon is very brittle like a non-metal, and it does conduct heat and electricity, although not as well as metals do. One other thing I want to add is that metalloids are Hopefully this video was helpful to explain more about what a metal, a non-metal, and a metalloid is. Thank you for watching.